Emostel.
Hello, this is Emmanuel Kadri and you're welcome to Emostel Academy. In this video, we'll be discussing expansion of algebraic expressions and then as a continuation of the previous video on the same topic. This time around, we want to deal with some examples that are a little bit more complex than the previous set of examples we dealt with earlier. All right, so check this out. We have x and then x plus 2, okay? Bringing this together, like trying to expand the bracket, okay? We can have let me just repeat the question here. X plus 2, okay? The same story. Whatever is it that is outside the bracket multiplies all the contents of the bracket one by one until there is nothing to be multiplied within that bracket anymore, okay? So which means x multiplies x, and the same x multiplies minus 2. Multiplies and plus 2, sorry. So x multiplying x will give you what? X squared, okay? X times x is x squared. All right, so if you say x times x times x, like x is the same thing as x raised to power 1, okay? And then x squared, x times x is saying x raised to power 2, and x times x times x is x raised to power 3, and so on and so forth. So the number of times x multiplies, I'm not talking about adding. If it is adding, if it was x plus x plus x, that would be 3x. But if it is x times x times x, that would be x raised to power 3. You understand? X raised to the power 3. So that's what it means. So x raised to power 1 is still the same thing as x. So that is why instead of writing x raised to power 1, you just allow the 1 to go invisible and then write it as x. But from x raised to power 2 and above, you must write it. Okay? But anytime you see x, just see x alone, it's still the same thing as what? X raised to power 1. Okay? The 1 there is meant to be invisible. But from x raised to power 2 upward, then you must write it. All right? So, I don't know why that thing called 1 is so belittled in mathematics to that extent. Yet, it's a very important number, okay? And it's like the most important number in the world. Let's continue. So we have x times x giving us x squared. Then the same x multiplied to give us what? 2x. That is x times 2 gives us 2x. See the difference between this one? X times x gave us x squared. X times 2, that is x in 2 places, gave us 2x. That is, you understand that? So good. So this one means x multiplying itself twice. This one means x in 2 places. So there's difference between the two. So x times x, x squared, x times 2, 2x. That's all. Then the next one, this is 3. You cannot go further. Haha, please. You can't go further beyond this place because this is x squared and this is 2x. Forget about the fact that the both of them have x. Okay, the way x is positioned in this one is different from the way x is positioned in the other. X here is carrying a power, and x here is being multiplied by 2. There is a difference between them, and therefore they don't belong to the same family, regardless of the fact that they both have an x. So if my name is Emmanuel Kadiri and another person's name is Emmanuel Johnson, the fact that we both have Emmanuel doesn't necessarily mean that we belong to the same family. So Emmanuel Kadiri is different from Emmanuel Johnson. That difference makes us not belong to the same family. So it is either you have Emmanuel Kadiri adding itself to another Emmanuel Kadiri or subtracting, but you cannot add Emmanuel Kadiri to Emmanuel Johnson. Okay? Only families mingle in terms of addition and subtraction whenever it comes to, whenever it comes to addition and subtraction, okay? And when we are dealing with terms, it's only like terms that can add or subtract. Only numbers that belong to the same family. I keep reiterating this because I want you to just, sink somewhere in so you would never make any mistake with that, okay? Now let's proceed. So, number two. Number two here says 3, 2 minus y, okay? The same thing we did here is what we are going to do here. So we just multiply whatever is it here outside by the content of the brackets, okay? So 3 multiplies 2 to give us 6. And then positive 3 multiplies negative y. That's plus times minus gives us minus. Then 3 times y gives us 3y. And at this point, there is nothing we can do again because they are not families. The terms are not like terms. So you cannot add or subtract. You just leave it like that. Okay? Good. Now, number 3. Number 3 is minus 2, x minus y. Okay, good. So to solve this kind of question, what you do is you have minus 2, because you just repeat this one. You only deal with the stuff that is immediately close to the brackets. You deal with what is closest to the brackets. And mind you, the sign here belongs to these 2, okay, like we've always discussed. So we are seeing these 2 as negative 2, multiplying positive x and negative y. That's the way we see it. So negative 2 in its completeness, we multiply x. Okay, the same negative 2 multiplies y. So as our tradition, we would always, consider the sign first. So minus multiplies positive gives what? Negative. And then 2 times x gives 2x. Then minus times minus gives us what? Plus. Then 2 times y gives us 2y. Okay? So at the end of everything, you have, there's nothing you can do at this point because this is 2, this is 2x, 2y. They cannot add or subtract, so you just let it be. And that is the end of that. Number 4. To solve this question, let me just write it first. 2 plus x, 3 minus x. This is a little bit tricky, right? Oh, yeah. But it's still the same thing, the same procedure. Look for what is closest to the brackets. Either what is closest to the brackets from the left or from the right, okay? Whatever is it that is closest to the brackets is what will operate with the content of the brackets. Mind you, if there had been a sign here, maybe plus or minus, then we wouldn't consider 3 as the closest number. We consider that plus or minus as the closest number to the brackets. Do you get? So if, for instance, we had it this way, if, for instance, we have it like, we had 2 plus x, okay, and then minus 3 minus x. Okay, if you have had it this way, for instance, okay, the closest guy to the bracket is 1, not even minus. Hi. Am I making sense? It's 1. If we had something like this, minus, if I have 3 minus, if you have 3 minus 2, if you had something like 3 minus 2 plus x, okay? The closest stuff to the brackets is minus 1. That's an invisible 1. Okay, so we use this minus 1 to multiply the content of the brackets. Okay, then we bring this 3 down and do. But in this case, we have this minus, and then we have 3 and minus x. So the minus does not belong to anything in the front. It belongs to this 3. Okay, now, it doesn't make this 3, whatever we have here does not make this 3 to multiply the contents of the bracket. Okay, because it is minus, because there is a sign separating between this content of the brackets and this 3, okay, then 3 does not have any business with the bracket. Neither does this minus have any business with the bracket because the minus belongs to 3. So it goes that way, okay? As far as this bracket is concerned, what is closest to it is 1. Let me write it again. We have 2. What is closest to it from the right-hand side is 1. It's as if we are writing 2 plus x, okay, multiplied by 1, all right? then minus 3 minus x. So that's just the scope. So this 1 is free to multiply everything here by saying 1 times 2, we have 2, plus 1 times x, we have x, okay? And then you repeat every other thing, minus 3 minus x. I know this is a little bit confusing to some people. It could be a little bit confusing to some people, but fine, it's still the rule. The rule is still the rule. Just identify the difference between we having 3 minus, in open brackets, 2 plus x, close brackets, and having 2 plus x minus 3. There is a difference. The difference between that is that here, the minus 1 interacts directly with the brackets, but here, okay, we are having minus 3. The negative sign here is after this 3, so it doesn't belong to this 3. It belongs to 1, which is invisible. Okay, the sign plus or minus always belong to the sign that follows them, not the sign before them. Only the sign that follows them. Now, this minus belongs to this 3. So because it belongs to this 3, we cannot use it as an operator to expand the brackets because 3 needs it. It belongs to 3. Here, this minus sign here does not belong to 3. It belongs to the bracket. It is closest to the bracket. It belongs to like 1, which is multiplying the bracket, okay? An invisible 1. That is what this minus sign here belongs to. So this one belongs to 3. It's not going to multiply the bracket. So as far as we are concerned, there is an invisible 1 here that is interacting directly with the bracket. You might decide to leave it there. You might decide to ignore it. Whether you ignore it or not, it is still going to give you the same result. Because if you ignore it, it only means that you just write 2 plus x, you write it out, and then bring down this minus 3, you bring it down, and then this minus x, and then you collect like terms. Okay? So I know some people will still have questions concerning this, but I would implore you to just watch the video over and over. So, but if you still don't understand, don't worry. Just send me a mail or send me a message on WhatsApp, you understand, and I will put you through. I will help you out. I will be able to find a simpler way to explain it to you based on how I assess you, how I assess your level of assimilation or your scope of understanding, okay? So don't worry about that. I got your back. So now let's go. We have, so we're going to do the same thing, something similar here. We have 2 plus x, okay, then 3 minus x. So you see that just as we believe that this 1 is directly linked to this bracket, okay, that is also how this 3 is directly linked to this bracket because no sign is in between. If there was a sign in between, then it will be like this, and therefore the 3 will have no business with the bracket anymore, okay? Then in that case, we will only repeat what we have here because there's nothing opening the bracket. We just believe that it is 1 that is opening the bracket, an invisible 1. So use the invisible 1 to open the bracket, and then you have the same content of the bracket as 2 plus 1. Then you repeat this minus 3 and this minus x, okay? So, all right. But here, in this case, there is no sign in between the bracket and 3. So we believe that the bracket, this 3, belongs to the bracket, is attached directly to the bracket. So because of that, we are going to have this 3 multiplies 2 and 3 multiplies 1. So, okay, the difference here is that instead of we doing it from left to right, we are doing it from right to left, okay? So 3 times 2 will give us 6, plus 3 times x will give us 3x, okay? Then you just repeat, this guy is just standing alone, so you repeat it as minus x, okay? Now, finally, we have 6 plus 3x minus x will give you, I'm having 3x, I'm owing 1x, so I'm still having 2x, and that's it. Okay, so that's that for that. Well, I really hope you're learning. Don't forget to ask questions if you don't understand. All right, number 5. Here is a little bit different case. We have 1 minus x, and then another bracket 2 plus x. How do we get rid of this? We have 2 brackets now. How can we open the brackets? It's very simple. The same thing we did here and here is what we are going to do there. Only that the numbers that are inside the brackets will take their turns in multiplying. They will take their turns, okay? For instance, we will start with 1, okay? 1 times 2, and the same 1 times x. All right? And then we continue minus x times 2 and the same minus x times x. So they will take turns in terms of the multiplication, okay? You know, in this case, it's only one stuff that we have outside the bracket. Here to only one stuff. Here to only one stuff closest to the bracket, okay? Here to only one stuff closest to the bracket. But now, here we have two stuffs, okay, that is trying to multiply the other brackets. So in this kind of case, you need to perform this method that the two stuffs, okay, the first one, they will take turns in their multiplication. This one will go first, multiplying this and this, then you take the other one to multiply this and that, and then that's how you expand the brackets. So let's see how it goes. 1 times 2 will give you 2. The same 1 times plus 2 will give you, plus x will give you plus x. Okay, now minus x times 2 gives you minus 2x. Minus x times 2 is like minus times plus is minus. X times 2 is 2x. Then again, minus times plus minus x times x, x squared. All right, so at the end of the day, so we have, we can collect like terms. These are like terms, okay? So we have 2 plus x minus 2x. I'm having 1x, I'm owing 2x. If I pay, I'm still owing 1x, then minus x squared, and that is the end. There's nothing more we can do in this case because all the terms involved are not like terms. You get that? Good. So, number 6. Number 6 says 3 x minus 2 and x plus 4. Okay? To solve this one, we have like 3 stuff now, okay? The very first step, excuse me, I want to explain minus 5 in another way, like a second method. Okay, please, I'm going to get back to this number 6, okay? It just got to my mind. If this method is not clear enough for you, there is another way, okay? The another way is that you will share the content of this bracket across this one twice. Let me just show you. You will say 1 multiplied by 2 plus x, okay, and then you say minus x multiplied by 2 plus x, which means the same thing that we did here is what we are doing here, okay? That's an alternative way. The same thing we did here, I need to just maintain the board. Let me just, let me see if there is, I can manage it here. So we have it as alternatively, you consider it as, sorry for that, sorry about that, sorry. So we consider it as this. 1, this first number here in the first bracket, 1, okay, multiplies everything in the second bracket. Then minus x multiplies everything in the second bracket, which is 2 plus x. Okay? All right, so that's how it goes. Now, we say 1 times 2 will give us 2. Still 1 times x give us what? Plus x. Like plus times plus plus 1 times x, x. Now, we go here, minus this guy 2 will multiply and then also multiply this way. Okay, minus x times 2 will give us what? Minus 2x. And then minus times plus is minus x times x6, x squared. You get that? Then we collect like terms. So however you have chosen to do it, you're going to get the same answer. So you collect like terms, you have 2, I'm having x and I'm owing 2x, then I'm still owing x. Okay, then minus x squared, and that's the end. Okay? If you pick it the other way around, you're still going to get the same answer. As far as this multiplication, you know, if you say 2 times 3, the answer is 6. If it's 3 times 2, the answer is still 6. Multiplication is commutative. So which means you can, it doesn't matter which one comes first or which one comes next, you're still going to get the same answer. Okay? All right, so if you have chosen to do it the other way around, that is, we want to distribute 2 plus x across this, okay? Yes, we can still distribute 2. We are very free to do that. So what we do is that we have, we can have 2, then we have 1 minus x, and then we have plus x, and then 1 minus x again. So we want to distribute 2 plus x across 1 minus x. That's what we just did here. You know, initially we distributed 1 minus x across 2 plus x. Okay, so this time around we are doing it the other way around. We are distributing 2 plus x across 1 minus x, 2 plus x across 1 minus x. So we have 2, 1 minus x plus x, then 1 minus x. Okay, so that's its distribution. Then let's go. So 2 multiplies this, that's 2 times 1 is 2, then 2 times x is 2x, then plus x times 1, we have plus x, and then this plus times minus is minus, x times x is x squared. At the end of the day, you have 2. I'm owing 2x, but I have 1x. If I pay, I'm still owing 1x, then minus x squared. You see that? However we have chosen to do it, we still keep getting the same answer. And so that's how it works. I hope you got that. Good. Number 6. To solve number 6, we have number 6 says 3, x minus 2, and then x plus 4. All right? So now we multiply this by this. The very first thing is try to distribute 3 across x minus 2, like use to multiply to expand the bracket with 3 first. Any answer you get, you now use it to expand the next one. That's the easiest method. Okay? So let's have it there. 3, this first, that's 3 times x, that's 3x. The same 3 multiplies minus 2, so we have minus 6. Okay? So we have 3x minus 6 multiplying x plus 4. Okay? So if we do it that way, then we will now do the distribution thing, or we just use this method to go straight to the points. Okay? So we can just say 3x multiplies x, the same 3x multiplies 4, minus 6 multiplies x, the same minus 6 multiplies 4. So let's go. 3x times x gives us 3x squared. The same 3x multiplies plus 4 gives us what? 12x. All right? Now, minus 6x multiplies x, we have minus 6 multiplies x, we have minus 6x. And then, you know, minus times plus is minus, 6 times 4 is 24. Okay? Then we can collect like terms. That is 3x squared. Okay? So I am having 12x and owing 6x. So it means if I pay the 6x, I will still be left with 6x. I will still be having 6x, then minus 24. Okay? At this point, I cannot do any addition or subtraction again. So you see that? Now, I can also decide to solve it another way around. Okay? So if I say 3x minus 2, okay, then x plus 4, I might just decide to deal with these guys first. I might just decide to deal with them first, okay, by saying, expanding, okay, just repeat this 3 and keep every other thing else inside. So x times x will give us what? X squared. The same x multiplies 4 to give us positive 4x. Then minus 2 multiplies x to give us minus 2x. Then minus 2 multiplies plus 4. That's minus times plus is minus. 2 times 4 is 8. Okay? It's still good. Then we have 3. Let's resolve everything here first. Okay? Now that the inner bracket has been removed, we can now convert the square bracket into a curved bracket. So then we now have we cannot change the square bracket to a curved bracket since there are no brackets internally to deal with anymore, no curved bracket to deal with anymore. Okay, so we have x squared minus 4x minus 2x will give us, sorry, plus 4x minus 2x gives us minus 2x and then minus 8. Okay, so at this point we cannot do any further addition or subtraction. Then you expand. 3 times x squared will give you 3x squared. Then 3 times minus 2x will give you minus 6x. Then 3 times minus 8 will give you what? Hope I'm not... Oh, yeah, there's a mistake here. This is plus 4x minus 2x. If I'm having 4 and I'm owing 2, I'm still having 2x, okay? Yeah, so this one is 3 times 2x, that's 6x. And then the same 3 multiplies minus 8 to give us minus 24. And then you still have the same answer as we had earlier. So however it comes, it's up to you. Just keep doing what is right and you will keep getting the right answer. That is the slogan. Okay, keep doing what is right, keep doing the right thing, and you keep getting the right results. So however you try it, anyhow you do it, anyhow you choose to do it, any method you choose to apply will still work, okay? In as much as you are following the rules and you are doing what is right. It is only when you break the rules of mathematics, when you do something that is not mathematically acceptable, that is the only time a particular step you took will not end up giving you the right results. But if you follow the rules and you keep doing what is right mathematically, anything you have chosen to do, anyhow you chose to do it, will still land you in the correct answer. Don't break the rules. So that's, okay, we still have one more question. I was just almost ending the class, okay? One more question to go. So I'm afraid I'm going to erase this. Okay. To solve question 7, we have x plus 1, x minus 2, x plus 4. Okay, just going to take this off. So x plus 1, x minus 2, x plus 4. The same thing that we did here, we could also repeat here, or what we did here. Okay, you can just keep one, or you can do the first 2 and leave this guy out first. You can just deal with the first 2 and leave the guy out. It's just as if you're trying to say something like, it's as if you're trying to say 2 times 3 times 1. If you like, first solve this first 2. 2 times 3, which is 6. Then you bring this one down. 6 times 1 is 1. Or you take this last 2. 3 times 1 is 3. Okay? If 3 times 1 is 3, then you bring this 2. Okay? Like this. And then it gives you 6. Anyhow you have chosen to do it, you keep getting what is right. You keep getting the right answer. Okay? Because we are dealing with multiplication, and then the position doesn't matter. What you did first does not really matter, as much as you follow the rules and you don't make mistakes. Okay? Good. So the same thing applies. This is multiplying this and multiplying this. So you can choose to resolve the first 2 or the last 2, anyone that is convenient, or even the first and the last, and then add this one to it, you will still get the same result at the end of it all. So let's expand. So I want to deal with this first 2 first. Okay? So this time around, you're going to say x times x will give us what? X squared. The same x multiplies 2 to give you, multiplies minus 2 to give you minus 2x. And then we have plus 1 times x, that's plus x. And then this multiplies this to give you, plus times minus is minus, then 1 times 2 is 2. Okay? We are still keeping tab with this, while this one is still outside. Remember, the bracket is important because they are together. Okay? So if I don't include these brackets, it will mean something else. It will mean x is multiplying everything here. Then whatever we get, 4 will add to it. So that is what it means. But so in order to avoid the confusion, still keep it in that bracket to maintain the status. Okay? Right, good. So we resolve this one. Now that we've, removed the brackets, so we can just keep it in a normal curved brackets like this. And so we have, excuse me, x squared, then minus 2x plus x. I'm owing 2x, but I have 1x. It means I'm still owing 1x, then minus 2, then open x plus 4. Okay? So this x plus 4, just bring it down, and then that's how it works. So as you have all of it here, okay, you can now, there's nothing you can do again here, then you can now subtract. You may choose to distribute all the contents of this bracket across x plus 4, allowed. Okay? Okay, let's do the distribution. So to distribute, we say x squared, okay, then multiplying x plus 4, close the brackets, okay, then minus 3, minus x, sorry, multiplies x plus 4, close the bracket, and then minus 2 multiplies x plus 4, close the bracket. Okay, so we distributed the content of everything here across x plus 4. It's allowed. So x times x gives us, x squared times x gives us x cubed. The same x squared times 4 gives us 4x squared. Okay, that is sorted. Then minus times positive gives us what? Minus. X times x gives us what? Okay, so x times x gives us what? X squared. All right, this minus times plus is still minus. Okay, so that's x times 4x will give you x times 4. Okay, sorry, minus times plus is minus, yes. So x times x, that's 4x. Then we proceed with this one. Okay, minus times positive will give negative. 2 times x will give 2x. Then minus times positive, negative again. 2 times 4 is what? Is 8. Okay, so that's how it goes. Then we have, we can now simplify. Just bring like terms together. We have x cubed, nothing else related to x cubed, but we have 2x squared here, right? So that's 4x squared minus 1x squared. It give us 3x squared. Okay, good. Minus 4x minus 2x. So if I'm owing 4 and I'm owing 2, altogether I'm owing 6x, then minus 8. I don't think there's anything we can do here again. So that's marks the end. So this is x cubed, this is x squared, this is ordinary x, and this is 8. None of them are related, none of them are like terms, so we just let them be. Okay, so that is that as per that. We've done a lot so far. We've been able to, treat different instances of expansion, different cases, different possibilities. We've just assumed a whole lot of possibilities for us to get to this point that we are. And I believe that at this point, there is nothing you need to expand or any kind of calculation that requires expansion that you won't be able to deal with. But if you come across any and you could not deal with it, you can as well send it to me through email or WhatsApp, and then I'll get back to you on it. All right, so that marks the end of this video. I hope you've learned a lot, and see you in the next video. Okay, in the next video, we'll talk about what we'll talk about in the next video. Bye-bye.